So welcome to the Titration Exploration video. So in this sort of mini lab exploration, what you're going to do is you're going to neutralize a 1 molar sodium hydroxide solution with 3 different acids. You're going to use a 2 molar hydrochloric acid solution, a 0.5 molar hydrochloric acid solution, and a 1 molar citric acid solution. And for each of the titrations, you're going to use 6 milliliters of of sodium hydroxide. So I'm going to add 6 milliliters. These pipettes go up to 3 milliliters, but I think it's easier to get 6 by going up to the 2 milliliter mark and adding 3 portions of those. So each of these containers have 6 milliliters, about 6 milliliters of hydrochloric acid. In fact, I can turn it around, it makes it a little easier for you to see the text there. Okay. So what I'm going to do is add my indicator, which is bromophthalo blue. I'm going to add a few drops to each one. Just swirl it around a bit. Now, in the base, bromophthalo blue is this nice, pretty blue color. But when the solution becomes neutralized, to turn green, or like a greenish yellow, and then yellow when it's an acid. So we know the concentration of the sodium hydroxide is 1 molar for each of these, and we know that we have 6 milliliters of sodium hydroxide for each. The question is, well, if I'm going to neutralize in trial 1 my 6 milliliters of 1 molar sodium hydroxide, how much of the 2 molar hydrochloric acid am I going to use? That's what I'm going to do for trial 1. So here you're going to make your prediction. Then you're going to test out your prediction. So once you've had your prediction, so I'm adding, this is the hydrochloric acid, 2 molar. Okay, so far I've only added 2 milliliters. And as you can see, still blue. I predicted I'd need 3 milliliters, so I'm going to start adding dropwise here. Okay, that was 3 milliliters. Okay, and now look, it has changed color to its neutralized state. So here I would write down my prediction was 3 milliliters and my actual volume was 3 milliliters. Alright, let's try this now with the next one, which is 0.5 molar. Now 0.5 molar hydrochloric acid is less concentrated than my sodium hydroxide. So what prediction do we have here? Well, if it's less concentrated, I'm probably going to need more of it. And in fact, since it's half the concentration of sodium hydroxide, I am going to need probably twice the amount. So since there's 6 in here, of sodium hydroxide, I probably will predict 12 milliliters. Let's see if I use 12. That would be 6 of these, so I'm going to go ahead. That's 2, 4, 6. I'm going to add half the amount and just swirl it a bit. Alright, so far I've only added 6 milliliters. Let's go for 8. Let's try 10. It's still blue, that means it's still a base, it's not neutralized yet. Alright, so we need, aiming for 2 more. We're going to add the last 2 milliliters. I'm going to swirl it, add it dropwise. swirl that last bit. It's still blue, so I'm going to add a little bit more. Now there's a 1/2 milliliter mark, so I'm going to aim to add about half that, just at the bottom there. Okay, and that's that purple thing. Okay. Still blue. I'll add another 1/2 milliliter. Suck up another 1/2 milliliter. Let's just add a drop. So far I've added 12.5. Another drop. It's getting a little yellow. And there we go. It changed. So I added, to get to the neutralized point, I added 12.5 milliliters plus 2 drops. Okay. All right. Let's do our last one. So our last one is citric acid. Now citric acid, it has the same concentration as sodium hydroxide, but it has, citric acid is polyprotic. So let's take a look at what that means. So recall with an acid-base neutralization, an acid and a base undergo a double displacement reaction to make a salt and a water. Essentially, the acidic hydrogen, which is over here, reacts with the hydroxide on the base to form the water, and what's left will form the salt. So in our first 2 trials, hydrochloric acid and sodium hydroxide, you'll see from the balanced chemical equation that it is a 1-to-1 mole ratio. So you get 1 hydrochloric acid, 1 sodium hydroxide, to make 1 sodium chloride and 1 water. On the other hand, if you look at citric acid, which is shown here, citric acid is a polyprotic. Polyprotic means more than 1 acidic hydrogen, or also known as a proton. See that Cu group? Each Cu group has the acidic hydrogen or proton. And since there are 3 Cu groups here, we actually have 3 acidic hydrogen and proton. That means that we're going to need 3 times the amount of sodium hydroxide to make 1 salt and 3 waters. So with that being said, in terms of predicting how much I need here, how much of the acid I need, here's what I'm going to consider. I know I need 3 times the amount of base to acid. So since I have 6 milliliters, and the concentrations are the same, by the way, they're both 1 molar, but I need 3 times the amount of base. So since there's 6 milliliters here, I'm predicting I would need about just 2 milliliters of citric acid. So even though they're the same concentration, it has to do with how many protons are here. Okay. So I'm going to suck up 2 milliliters, and I'm going to see if that leads me to a neutralized solution. Let's use blue right now, and again we're aiming for green. Okay. Let's just see. Yep. So I use a little less than 2. I use 2 drops less than the 2 milliliters. So 2 milliliters minus 2 drops. So pretty accurate here. Okay, so I have all of my neutralized solutions. I have the predicted amounts and then the actual amounts, and you'll notice that they were pretty close. So I was able to predict the amount of acid I need for each one based on 2 factors. The number of protons in the case of citric acid, and also the concentration of the acid as well. All right, I hope you found this video helpful. Have a quality day.